Hey, how you guys doing? It's me, Elric, back here on the Motherboards.org YouTube channel, Tuesday, April 17th, and we have a very special guest in the house today. Today, we have Mr. ROG himself, JJ from ASUS. That's right, he's here, and today we're going to be talking about their entire new Z77 lineup. Now, a lot of people out there compare motherboards just by the bottom line specs of a board. And every chipset basically has a set of specifications, so doing that makes no sense. So what ASUS has done is they've come out and they've created their own baseline, or what they call no compromise features, on their entire stacks of motherboards. And that's what we're here to talk to you about today. So I'm going to jump over now and we're going to let JJ introduce himself and start explaining some of these features to you folks. So what's going on, JJ? Welcome.
I'm doing all right. Thank you for having me. I appreciate you letting me come by and give you, as well as the viewers, the opportunity to let you guys get a little bit of information about our design philosophy and what you discussed, which essentially is our kind of non-negotiables and the focus points that we have when it comes to what do we do as a motherboard vendor when it comes down to actually integrating the components and the feature set on our boards, right? Because I think that's a question you get a lot of the time, right?
Yeah, a lot of users don't know that.
Yeah, I mean, and it's a question of, what's the difference between this model or this model, or let's cut past the marketing terms. If you have something like a digital power design, what's the relevancy behind that? And so I think what we want to try to do is help to communicate that and also help you understand that we're not necessarily going to pigeonhole you to one specific board. We want you to be able to feel comfortable and pick any one of our boards, but base it off of what's going to be sensible on your usage model. So with this Z77 chipset, it's really been an evolution of a lot of the things that we've been working on, especially since P55. So since that, we've really been looking at, for one, the utter basic levels of what you should have when you're designing a motherboard. So this is just sensible stuff. Like, let's say when we talk about a board and we talk about PCIe slot spacing, it makes sense to have dual slot spacing, right? So if you put two graphics cards, you have a slot in the center so that you have breathing. So if you're running SLI or Crossfire, you're not having the two cards impacted together, right?
Which makes for better cooling efficiency as well.
Of course. Or like, when we go ahead and we put right angle serial ATA connectors on all the boards, so then that way when you have in a longer profile graphics card, it doesn't impact, right? So those type of things are very low level, right?
Let's just real quick, JJ, let's show the users what we're talking about. When he's talking about that, he's talking about these things right here. You see how these things are mounted sideways so that you can very easily plug all your connections, everything into these SATA ports? Those are the type of connections that he's talking about, correct?
Yeah, 100%. And those things seem small, but they're important to the user, because if you screw up on basic elements like that in terms of the slot layout or how things are laid out on the board, then you might automatically, even if there's other features that you want to know about or you might be interested, you might just say, I'm going to go to a different board. So at that point, we started looking at all those key aspects and saying, what makes sense based off all the feedback that we're getting from our users. We work with system integrators in terms of integrating our product, that they get out to one users in one way. We've got do-it-yourself guys. We've got people like you that have a lot of experience that look at the product. So we pulled all that information and we started to do that. Now we move forward to where we're at now. So what are we doing specifically for Z77? With Z77, we wanted to essentially take a whole bunch of key technologies that we've been doing for now multiple generations and push it further. So first and foremost, we've got our digital power delivery. So digital power delivery is now in its 9th generation for ASUS. So we've had that, X58, P67, Z68, 900 series from AMD, FM1, tons of chipset. Every single chipset we have right now has digital power delivery.
Now let's just explain to the users too. For you users out there, that's when you see the motherboard says Digi plus VRM. What JJ's talking about now is the digital aspect of those two combination of words, correct?
That's correct. Now, what does that actually do for you at the end of the day, right? Because that's just essentially a buzzword. It's a marketing
word, a marketing term.
Right. And what we wanted to execute when we incorporated digital power controls was actually give you control and flexibility and granularity. So we have a lot of specialized options like load line calibration, OCP level controls, the actual transient response, the phase management, all the parts that you talk about on board, the power delivery section. This can all be modified in the operating system or within the UEFI. And there's actually some advantages, even when you're talking about overclocking. When you have this digital level of control, you can make adjustments to the multiplier to voltages seamlessly and accurately. And think about it, you don't actually now have to keep rebooting the system. So I could bump up my multiplier, make an adjustment to voltage, maybe adjust the load line calibration and then the OCP, and run the stress test all real time without having made one reboot, right? Because when you do that on the UEFI, it's that classic process of make the adjustment.
Exactly, stop, rebooting,
go
reset.
To Windows, crash, make the adjustment, boot, recrash, and go through over and over and over and over again. So you can actually really get a huge amount of time savings. So for this generation, we now have digital power delivery control for the CPU, for the VRM assembly, So that's going to give you control for things, like I said, like load line calibration, the actual phase management, the transient response, a lot of different things that are very technical in terms of overclocking or efficiency parameters. We then also now have control for the DRAM. So we can go ahead and control those functions. Specifically for Z77, we actually even have the ability where we've laid actually little what are called thermosistors. They measure the temperature underneath the VRM as well as actually for the DRAM, and we can adjust what's called the junction point. So if these components get too hot and maybe induce what's called throttle, where the CPU frequency comes down, we can actually increase the actual throttle point from, let's say, like 130 to like 150. That's all real-time available UEFI, the OS. Now, in addition to that, for Z77, we've gone ahead and also included digital power control for the iGPU, so the graphics core that's inside the CPU.
Exactly. So when Ivy Bridge launches, you're going to actually have that control directly in the onboard graphics contained in the Intel CPU. Yeah.
So
incredible.
For essentially this whole top side of the board, right, on any one of the boards that we're talking about, you're going to have that level of control. So CPU, iGPU, VRM, the DRAM, and all the relative parameters of even frequency or from voltage tables. They're all configurable.
And that's going to basically translate to the end user, though, is that every single solitary motherboard that they have on this new launch and the entire stack has the same basic overclocking features. Yeah. You'll be able to do the same overclocking all the way from this little tiny board that we have over here all the way up until their top major board, other than the ROG series, will be exactly the same. So you're not sacrificing anything.
That's a great point to actually make, is that we spend a lot of time in terms of that digital power control and the tuning to allow you to essentially get the same OC experience here. We have a standard board. This is our entry-level SKU. Okay, so this is the entry-level at Z77, and it's going to provide the same overclocking experience as if we were to go, let's say, and take a look at our deluxe board. This is our premium kind of like high-end board. Gives you all the connections. You know, it has the highest phase count, the most robust VRM heatsink. But that being said, you're going to get the same overclocking performance across the board. So we don't want that to be the limiting factor. We don't want you to say you've got to buy this board to get this result.
Yeah, that's basically one of those baseline things where you're just not going to sacrifice at all. Everything is the same from the ground up, so it basically levels the playing field for users with that. Which I think is a very good thing, because then people don't have to wonder, well, if I want to overclock, do I got to get this board or that board? Basically, if you want overclock, it doesn't matter what board you get. You just need to look for the specific other features that you're looking for, correct?
100%. And with that segues actually, I think, into the next aspect, which is we're going to talk about some of the unique characteristics that, once again, are consistent across the board, but step past the whole point of, let's say, marketing spec, right? Because spec is very easy to compare when you're talking about, let's say, the number of fan headers from one board to another board. But when you talk about the usability or the functionality, can I actually control those? Do they control both 3-pin and 4-pin controls? Can I calibrate them? This is a key area that sometimes gets easily overlooked, but it's actually one of the more expensive parts of board design, because what a lot of people don't know is there's a Super I/O controller on the motherboard. So this is a specific sensor and controller that actually gives you functionality for every single one of the headers that's on a board. So take, for instance, on our standard board, it's a minimum of 5 4-pin PWM fan headers. Okay, and if we go up, we go only up from there. So every single board at a minimum has at least that those 5 4-pin PWM headers, except for, of course, the mini board, because it's a mini board.
A little smaller.
Yeah, of course. But relative to our ATX, we go from 5 and up. Now, the cool thing about that is that Super I/O controller that we've incorporated, we allow for full control functionality for all of those headers. So that means that if we go ahead and connect a fan to every single one of those, we can actually control that, not only within the UEFI, but also within the operating system. And we're not just talking about a basic on or off level of control.
No, you're talking about like a sliding thing where you can actually increase the fan speed and see it in real time what your RPMs are of the spinning fan, correct?
Definitely. And in the operating system, it's very, very extensive. But even within the UEFI, we have 3 presets. So we have silent, standard, turbo. You have a manual option where you can pick the maximum rotation, the minimum rotation, and even base that off of temperature. So if, let's say, you want it to go to 100%, when you've gone ahead and selected a temperature of 70 degrees, that's what's going to occur. Now for Z77, we've gone ahead and made some updates. So if, let's say, we would look here at our standard board, where we have some chassis fan headers, such as like this is a chassis fan header, this is a chassis fan header over here, and we've got like another one over here. We've added actually 3-pin fan support. So we give you the capability of controlling both 3-pin fans and 4-pin fans.
But also from the same controller, right?
Yeah, so it's all functional. And the main reason why we do that is because we listened to our users and we heard feedback that said, you know what, there's still chassis on the market where a lot of the chassis fans are 3-pin, where the majority of CPU fans for like your coolers, like, you know, an Antec Cooler 920 or a Corsair H100, they use 4-pin fans.
Exactly.
Or you might upgrade and choose your own fans, which tend to be 4-pin PWM, because those are the nicer fans that tend to be on the market.
I believe so as well.
Yeah. So that's one key area where definitely you're going to see differences, especially if you compare at the entry level and even at the higher end level for competitors. You know, they might only have maybe four or 5 fan headers, and they're going to be mixed. It's going to be like 2 or 3-pin. Some are 4-pin, and the control options are very limited. It's usually maybe a basic slope option or on and off.
I admit a lot of the boards that I have seen do not have nearly as many fan headers as your boards do as a standard. Many of them are lacking. It's very true, especially with on the 2 fan headers above the ZIF socket, which is a very important feature for a lot of the technologists out today.
And actually, that's a great point too that you made that I missed is positioning. You know, we've made sensibility. If you take a look at all the keyboards, we've positioned them here actually on the board to be right at the top. And it's just a sensible thing, right? I mean, if you've got like a tower heatsink, right, where you're running a push and pull fan configuration, which is what most people are running in a high performance setup, you want to be able to go ahead and connect those fans easily so you can have nice clean cable management, right? But those are the things that make sense, but sometimes aren't always focused on. And this is the other kind of thing when we talk about value. When we talk about our like kind of entry-level SKUs having all these things that we're going to be covering, we feel that these type of design implementations make more sense than sometimes just talking about like how many PCI by 16 slots does it have.
Exactly, because as you stated before, and we've actually come to agreement on, most people only use a single video card.
Right. Now, it doesn't mean, like you said, that we're not going to go ahead and have boards that have, you know, 4 by 16 slots. You know, we're going to definitely make those boards.
But that's just a different option on a different board on that feature class.
Right, exactly. So I think from here, let's move over to maybe the back I/O.
All right, you want to start off with talking about this new wireless to go?
Yeah, that's definitely an option. So all the actual boards will come included with what we refer to as our Wi-Fi Go module. And so at a minimum, like you said, standard board has Wi-Fi, Pro board has Wi-Fi, Deluxe has Wi-Fi, but we step it up. It's dual band Wi-Fi, so you get 2.45 gigahertz and Bluetooth. So, you know, we do make improvements as you go up the board stack, but if the majority of users only need, you know, single band wireless performance, then that's where it makes sense for them to go, let's say, to the standard or to the Pro. But if they want even better, then of course they can step up to something like it's on the Deluxe boards.
Now, another thing that you guys are going to really think is really cool, at least I did, is with this, you can actually control both ways the information on a system. So you could be on your laptop in the living room and have this installed on your motherboard in the kitchen, and you could actually go in there and control in real time all the stuff on your laptop. So you can go in there and take all the information from that system and show it. Not just like sharing information. I'm talking about playing music, streaming video, and just looking at anything on the computer in a much greater fashion. True?
Yeah, we've got a lot of functionality that we introduce because it's more so than just about giving you wireless. You know, wireless is great, you know, in terms, our data is showing us that about 25% of users are now taking advantage of wireless on their desktop as opposed to using an Ethernet connection. But we want to give you more functionality, like you said, DLNA media streaming, where we can go ahead and stream and control from the desktop, sending those files out like pictures, music, videos. We have quick and easy file transfer. We have remote desktop, and there's even more. So I think let's go ahead and keep moving back on that back I/O.
Okay,
so
we'll show this over here to the people
one
out
of
there.
the next items directly below it is you're going to see those 2 blue ports. Those are USB. Now, of course, one of the things that Z77 is adding is native USB 3. That's great, but how do we make it special? We've added a new special technology in terms of a software package that we have that's called USB 3 Boost. This allows us to change the operating mode of the USB transfer system. Now, USB has been around for a really long time. We've gone through USB, the original spec, then USB 2, and now USB 3.
Yep.
But the protocol mode to transfer files has essentially stayed the same. It's called BOT. The BOT protocol mode, though, doesn't really know how to take advantage of the higher bandwidth that's available for USB 3. And with our USB 3 Boost software, we can change it either into what's called SCSI or to the most advanced mode of operation that's called UASP. Now, what this really translates into is faster performance.
Okay.
Take, for instance, the Intel controller. When running in bot mode with a high-speed storage device, you're going to get a little bit under about 275 to 300 megabytes for read and write performance. With the same exact setup, but shifting into turbo mode with our USB 3 boost, we can do over 400 megabytes read and write performance.
That's quite a significant gain.
That's correct. And that's what it really comes down to, is a tangible benefit in terms of performance. And I think that we'll definitely show later on some of the cool functionality that you have with USB 3 boost. And this technology will also work with our add-in controller. And there are actually some benefits to the add-in controller even versus the Intel one. So our focus isn't saying one is better than the other. It's more so use the right one that's going to benefit you depending on your work usage.
Well, let's also talk about the amount of voltage being provided to the USB port, yours compared to other ones. Now, the other ones run off, what is it? Is it 5 milliamps?
Well, the USB 2 port in itself, so when you look at a board, these ports right here, those provide generally a maximum of 500 milliamps, okay? And there's competitors that sometimes allow you to tweak and tune those and change that to put more than that. Now, the USB 3 ports inherently can provide up to 1500 milliamps. Now, one thing that we're doing that's special for this generation is we have a technology on all the boards. It's called USB Charger Plus. Now, we've had a pre-existing technology called AI Charger Plus. This essentially lets you charge Apple devices very fast, but also during any S state. So that means like if you turned off your computer or if you had it in sleep or hibernation, it would still charge. That's all well and great, but you know what? I've got a lot of stuff that's not Apple devices.
We were PC guys. So I mean, exactly. I admit it, I have some Apple stuff, but hey, I'm mainly PC. But now this will power all those PC devices in the same format, right?
We have a port on there so that if you had, like a smartphone, if you had like a Transformer Prime, you had different devices, you can go ahead and connect that and still get the same exact benefit. And we actually keep both of them. We keep the AI charger and the USB Plus charger. So moving along from the USB Charger Plus technology, we've got, of course, network connectivity, right? So what's special about that? In terms of network connectivity, we've been a big proponent of putting a higher class of controller on the boards.
Which is the Intel controller versus a Realtek, right?
That's correct. And that really came back from the feedback of our users. They said, look, we were looking for a better quality controller that gives us better performance, better compatibility, lower CPU utilization, as well as really robust management. Not a lot of people actually look at it specifically, but if you go into the driver for the Intel Pro set, you have a lot of really cool stuff you can do in terms of VPN, enabling jumbo frame support. You can even test the length of your cable.
Oh, yeah.
You can check if it's actually functional. You can do a lot of really cool stuff that you get with a higher class of NIC.
Not to mention the low ping connectivity that maintains with the Intel chipset. The Intel chipset just seems to have a lot better transfer rate and less drop off from the Realtek by a mass margin, I feel.
Well, yeah, and performance also, when you really start to load it up and you throw a lot of larger files at it, you get really, really strong levels of performance. The other technical benefit is that the controller, when it's used natively, it's part of the chipset design, so we don't have to use a PCIe lane to that controller.
Just eventually freeing up more bandwidth.
Exactly, more bandwidth to either put another controller or just leave it free so that we have more bandwidth for the board. So that's a nice, sensible implementation. For this generation, though, we've taken it further. We essentially put Intel LAN on every single board once again, but we added packet priority software. So we have this cool piece of software called iNetwork Control. Lets you go in, let's say if you had Steam or if you had, let's say Hulu
Origin.
Desktop, Origin, Chrome, whatever it is, you're going to see all these little network services. You can go ahead and click on it. You can prioritize it so that if you're a gamer, prioritize that client. If you're web browsing, prioritize that. If you're a streaming guy, prioritize that. It's very flexible. All you're gonna have to do is just select it, click it, and that's it. You're good to go.
Exactly. So folks, I know you guys a lot heard about the Bigfoot LAN solution. Well, basically the new Intel solution covers all of those same features within its own solution. So it's really damn good stuff.
I will make the point though that we work in conjunction with the controller, so that iNetwork Control isn't inherently part of the Intel. So even if you did see another board with that Intel controller, it's not going to have that network iControl function.
So this is only strictly on ASUS boards.
That's correct. So we've added that in addition to the Intel LAN controller.
Just another one of those no sacrifice things.
Yeah, definitely. Next one right below that, it's a two-part package. So it's going to be this actual USB port, and it's going to be the USB BIOS flashback button. So we added this. Actually, it was on all our X79 boards, and it originally came on our really high-end ROG boards. But this is a cool technology that lets you go ahead and update the BIOS chip. So that's this little chip here on the motherboard. So with the USB BIOS flashback implementation, we have the ability to go ahead and update this without a CPU, without memory, without a graphics card. All you have to do is just have the PSU connection here, the 24-pin power, and then the CPU power. Those are the only two that are required. And you just plug your flash drive into the port, hold down the button, and it will update the motherboard for you. It's a really high-end technology. It actually requires some special hardware for us to put the board, because essentially we're almost running the board, but without all those other components. And This would also work from actually a recovery standpoint. Maybe you overclock the board too hard. Maybe like a surge, spike, or sag occurs when the system is running and it compromises the boot ROM. You could still go ahead and do that same thing and go ahead and get up and running. Pretty
That's
cool.
Really nice stuff.
Moving past that, we've got audio, right? Now, everybody essentially has these same type of connections, and a lot of the competitors are using the same type of Realtek sound solutions. What we've done to distinguish ourselves is we're working with DTS, and we have a special package called DTS Ultra 2 PC. Now, within this package, you have some really cool pieces of software like DTS Connect. This lets us go ahead and take any standard 2-channel content, re-encode it hardware into multi-channel, and then go ahead and dump that out to, let's say, like a digital pair of speakers or receiver, and be able to take advantage of that multi-channel audio.
Now, does that work in games as well? Like
Definitely.
If you're playing a 2-channel game but you add 5.1 speakers, it'll translate that and just basically simulate the 5.1 environment for you?
That's correct, but it's different than other mechanisms. Like in previous boards, we had DTS Sensation, but we listened to the users' feedback and they said they didn't like Sensation. It was like an upmix technology.
It wasn't a good sensation?
Yeah, it wasn't that good of a sensation, correct. So we went ahead and we went to a different, more advanced implementation with this DTS Connect. So that gives you a lot more usability to the multi-channel support that the board is offering. So that's a pretty cool plus point as well.
And it uses what, the Realtek ALC 9888 chipset?
898.
898 chipset, okay.
Mm-hmm. So that takes us over from the audio. Let's take a look at maybe some of the other interesting connectors that we have on the board. Now, one of the most special ones is I think ones that a lot of your guys are going to be very interested in. This chipset has had a lot of stuff being talked about Thunderbolt, and it being now native to the chipset. Now, it's not inherently native to the chipset. There's no obligation for the manufacturer to put it on the board, but it can be supported on this platform. With ASUS, what we wanted to go ahead and do is give this flexibility to essentially have almost any user adopt this on a Z77 board. With the exception of about 2 SKUs, they're all going to have a special header. So let's go ahead and see if we can show this
that
header right
header
here.
to the people out there.
So if we reference it, should be right here. If we just tilt it down, you see it says TB header. So this is going to be a great easy way for users to go ahead and purchase our expansion card, which will come to the market. It'll be between about $30 to $40. They drop it into a by-4 slot. Little cable runs from that card to that header, and now you have Thunderbolt enabled on your system. The great benefit of it is one, it's a really high-speed, high-performance interconnect that has daisy chain support for like displays as well as
External
for data.
hard drives, everything.
All kinds of stuff. But you're not going to have to pay for it if you don't necessarily need it right off the bat. But you're going to have that flexibility of being able to add it to essentially any one of these core SKUs by just dropping in that card.
Right, so if a user basically buys the board, then 2 months down the line, he decides he wants to get an external Thunderbolt hard drive, he can go ahead and pay for this and just be up and running through Thunderbolt technology, correct?
That's correct. So we've tried to make it very seamless, very easy for you to have that flexibility of jumping onto our boards and being able to support Thunderbolt.
I'm glad to see it. I think a lot of other people will be too.
Yeah, definitely. Moving past from that, I know one of the big things that we get a lot of questions about is our TPU and EPU processor technology, right? So we've called this dual intelligent processors for now a couple of generations. So if we take a look at the board, take for instance, we have here, this is our EPU switch. And on that side of the board, we've got one that's the TPU switch. And the TPU and the EPU are essentially 2 specialized ICs that help to focus in on power efficiency, reduce power consumption, and control power management functionality. That's on the EPU side. With TPU, it helps to give us this advanced monitoring, more advanced voltage control, and specialized functions like that. Now, what these switches will actually do for you is pretty cool. If let's say you have like a 3770K, bam, just flip that switch, you're talking almost 4.3 gigahertz with just a flip of a switch.
That's what the users want to know.
Yeah.
They really want to know what that switch actually does for them in a nice layman's term, and that's it. That's a good way to describe it.
And the same thing, the EPU switch is actually the opposite. It's focused for people that want to run stock operation, and they want lower power consumption, and they want maybe better idle temperatures and low temperatures. It's not going to affect performance at all. All that switch is going to do is provide less voltage to the CPU, and it's going to still allow it to run correctly, but you're going to get, like I said, lower power consumption and reduced temperature. So it's up to you. Either go the power efficient route or go the overclocking route. Now, the great thing about this, though, is that switches are good when you're first setting up a system, right? But what happens if you put inside of a chassis? Do I want to go back into the chassis to flip a switch? Probably not. So the flexibility that we have with this is that you can still go into the UEFI, and you can access the TPU and the EPU modes from within the UEFI, or you can do the same thing within the operating system. So at any stage
Also,
that
the
you have
digital connectivity with that digital controller, you'll be able to control all this from either environment as well. You don't even have to go and touch the board again.
So if you wanted that 4.3 gigahertz overclock, but you've already installed your system, you could go in the UEFI and click one button and make it happen. If you didn't ever feel comfortable going in the UEFI and doing that, just go into Windows, go into ASUS2 and click the fast button, and it does the same thing.
That's very ergonomic.
Yeah, so we give you essentially the flexibility at any stage that you have your system set up to be able to take advantage of our EPU and our TPU technologies. So outside of that, I know that one thing that we talked about was ESD technologies that you found very interesting.
Yeah, a lot of people don't know this, but I had a technician working for me. I won't mention any names, but a couple weeks ago, he had a board and he plugged in a USB device and he told me that he fried the board. And I kind of just thought he was fooling to know what he was doing, but he was walking around and created static electricity. Now, ASUS has put a bunch of different ESD components on their motherboards to make sure that this doesn't happen by allowing the motherboard to switch off and not allow the electricity coming to the board and shorting it out. Correct, JJ?
Yeah, essentially these ESD guards are fail-safe mechanisms so that when the static discharge comes in, essentially it's received, discharged safely, as opposed to flowing to more sensitive parts of the motherboard, like what's called your PCH. There's a chip underneath here, right, that controls all the SATA functions or USB port functionality. So if the static discharge were to come through, let's say one of these USB ports right here, right, it's going to generally flow to the PCH. So we're helping to stop that with a special set of ESD guards that we have sprinkled out across all these ports. Now this is sometimes harder to see, but it also adds a bit of cost to our boards, which is why the reason why our premium as well as even our value SKUs sometimes are priced a little bit higher, but it's also that we're essentially allowing for a longer, more reliable lifespan for the product.
Excellent stuff. One thing also, JJ, I just want to mention is a lot of people I don't think know about what you told me about the MemOK button. Like all of us know that you can put your memory in there, you click the MemOK Go button. If your memory's not correctly, if it doesn't have the right frequency, it'll set it to that. But also, this can actually be used in the overclocking environment as well, because if you've overclocked your motherboard and the frequencies aren't right, you can hit this button and it'll clear those frequencies out, but it will not erase your BIOS settings. So you don't have to go through the same rigmarole of shutting the system down, resetting it up, and resetting the BIOS time after time, correct?
Yeah, that's correct. So I think that gives a little bit of a perspective regarding a lot of the specialized technologies that we have consistently across all our boards. It shows that, we spend a large amount of time to listen to our users and hopefully give them a lot of value.
Yeah. I think it's a really excellent thing that all the way across the board, you guys have basically raised the standard for everybody, and it's going to be hard for a lot of people to come up when you raise the bar of a standard like that.
Well, Doc, I definitely know that you guys are going to go more into information with the other videos that we show, the videos you guys do in-house, as well as your guys' written reviews. So definitely, as always, I recommend you guys check that stuff out because you guys are going to focus in on that detail and give even more information on stuff that we haven't covered here.
Just one last thing before we go through the audience. I know a lot of people out there get confused when they're buying a motherboard. The basic thing to do is you need to figure out what you're going to be doing with your board and then take a look at the different features that they have between each segment and then make your choice based on that. And just remember that all of the basic great features are going to be inherent all the way from the bottom to the top of the stack. And I think that's very important. I'm Elric here with JJ on Motherboards.org. We thank you guys for watching. We have more videos coming up with more ASUS goodness.